This program is made possible by a grant from the National Science Foundation, a co-production by Mississippi Public Broadcasting and the University of Southern Mississippi Gulf Coast Research Laboratory. April 20th, 2010, 41 miles offshore in the Gulf of Mexico, BP's Deepwater Horizon drilling unit exploded after high-pressure methane gas engulfed the rig and exploded. 11 people would lose their lives that night. For nearly 3 months, oil gushed into the Gulf of Mexico. Marine life, tourism, and petroleum operations will never be the same in the Gulf region. Now there are questions that have scientists focusing on trying to shed light on the unknown long-term effects on the Gulf. This is the Science of the Spill.
Hello and welcome to the Science of the Spill. I'm Erin Pickens.
And I'm Dr. Bob Thomas, Director of the Center for Environmental Communication at Loyola University.
The Science of the Spill is produced by the University of Southern Mississippi Gulf Coast Research Laboratory and Mississippi Public Broadcasting to inform the public with scientifically proven facts concerning the BP Deepwater Horizon oil spill. And Dr. Thomas, I think we can all agree that there are many myths and some information out there not based on scientific data about the effects of the spill.
That's right, Erin. We're going to bring together scientists that are studying this disaster for informative discussions to give the facts about issues related to the Deepwater Horizon oil spill.
Now, we also want to let you know that you can find more on our companion website, SpillScience.com. There you can find in-depth information about topics related to the spill, as well as video discussions from scientists studying the effects of the spill on the Gulf of Mexico. You may also want to join the discussion on our blog section of the site, where you can engage in discussions with scientists studying the impacts of the Deepwater Horizon oil spill. Again, that's SpillScience.com. Well, Louisiana has suffered a loss of its coastal wetlands at an alarming rate for many years. Has the oil spill had any impact on this problem? We visited with scientists and traveled to an area in Louisiana directly impacted by the oil, Bay Jimmy and Barataria Bay, for a first-hand look at this issue.
I think a lot of people in Mississippi and Louisiana and this part of the Gulf Coast are very interested in the natural progression of their coastline and the fact that we're losing a lot of coastal land every day. A lot of people are worried that by introducing oil at high concentrations into these ecosystems, that it will inhibit the natural processes that trap sediment and help counterbalance the loss of these coastal environments. So our research will hopefully help determine whether geomorphologic changes, that's a fancy word for changes in the rate at which we gain or lose coastline, that will hopefully help us determine whether or not changes in these processes can be linked to the oil spill.
So here we are out in Bay Jimmy, which is on the northern part of Barataria Bay, and a lot of oil accumulated out here in Bay Jimmy. It came up through the passes. There are some passes that are due south, passes being the term down here for tidal inlets. The oil came through the passes and probably got washed ashore on the edge of these marshes under the influence of southerly winds. Over there you can see where the oil is and has been. Some of the darker spots over there are most likely still oil. You can see that the oil stayed in the front, let's say 5 to 10 yards of the marsh. This is something that seems to have been something of a widespread pattern. We've often talked about marshes as good traps and good filters, and this is probably the best example I've seen of it, is that the marsh grass has trapped much of the oil in the front 5 to 10 yards. So I think that while this spill was certainly a nightmare and a disaster, it has to be put in the context of a coast that is unfortunately in a state of degradation. So what we've got here is a bunch of plant stems and plant roots and old plant material, and this was most likely all marsh, some years ago that has sunk into the sea. So this is part of the story of South Louisiana is right here in this anchor. If you take the amount of shoreline that was oiled and you multiply it by the length of the width that was actually oiled, you multiply several hundred miles by something that's maybe 10 yards, you only get maybe on the order of 10 square miles or less of coastline that was impacted, which is incidentally less than the amount of coastline that we lose in an average year. We lose somewhere on the order of 25 square miles of coastline in an average year, and in a bad year, much more than that. In the month surrounding Katrina and Rita, the coast lost somewhere close to 250, maybe a little less than 250 square miles worth of land. One thing that you can see is that the oil did lead to some mortality of the marsh plants. You can see what appear to be some dead marsh plants over there. The brown marsh is most likely dead. You can also see in the middle over there, you can see some new shoots coming up. And those are most likely shoots that have come up since the oiling event. So it's most likely some regrowth after the marsh, after the oiling event. The basic story, I think, of what's going on is that the plant roots didn't die. One of the biggest concerns people had when this oil was when the spill was breaking, was would it kill the roots? And people asked myself and people asked other people, will everything die off? And a lot of people said it depends on what happens to the roots. If the roots die off, we could lose the marsh, and by extension, if the roots don't die off, things can regrow.
I think if we had proper restoration efforts in place decades ago, we would have had complete barrier islands like the Chandler Islands. We would have had complete marshes in the Biloxi marshes. And it's just the physical nature of things. You have more avenues for this oil to enter. So if we had complete marshes in the Biloxi marshes, yes, we still would have gotten damage, but so much of the interior marsh, which is very important for juvenile organisms to spawn, would still be intact. We probably would not have seen oil getting as far in as Lake Pontchartrain. It's just a matter of physics. If you had more physical boundaries between the oil and the interior marshes, we would have had less problems. Now let me also say, though, that we need natural barriers. If you're throwing artificial barriers up there that will not be permanent, that are not held in place by plants and root systems, it's a waste of time. You need to support the natural restoration of the marshes and of the barrier islands.
It was very interesting to examine the added ingredient of the oil spill on larger, longer-lasting issue of coastal wetland loss in Louisiana. Let's turn to Dr. Bob Thomas for a discussion on this issue with our in-studio panelists. Bob.
Thank you, Erin. Our panelists today are Dr. Mark Peterson, who is a professor of coastal studies at the Gulf Coast Research Lab in Ocean Springs, and Carrie St. Pé, who's the executive director of the Barataria-Terrebonne National Estuary Program in Thibodaux, Louisiana. Mark, tell us something about your research background.
My research deals with fish ecology mainly as it relates to salt marsh and coastal habitat and losses or impacts of those habitat and how it impacts fishes and crabs and shrimp and things like that.
And Carrie, your background?
I spent my years after college in working for the state of Louisiana in the Division of Water Pollution Control, and for the past 13 years I've been director of the National Estuary Program.
Well, Dr. Alec Holker of the Louisiana University Marine Consortium pointed out that that all of the coastal wetlands that have been impacted by the oil spill thus far amounts to less than we lose in coastal Louisiana in a given year. Give us a background, Carrie, if you can, about why this historical loss of Louisiana coastal wetlands has occurred.
Well, in southeast Louisiana is a product of the Mississippi River. The Mississippi River drains 2/3 of the United States, and every year after the spring floods, after the snow melt, we had this enormous amount of sediment coming down here with the water, and it would flood its banks, depositing new silt on the sinking coast. The coast has been sinking for 10,000 years. It's just that it was offset, the sinking, with new layers of sediment. The river changed course about 8 times over geologic time, depositing new deltas and building land. In the last 75 years, we've destroyed that sequence of events that built the land. We've levied off the Mississippi River. And more importantly, perhaps, we've built locks and dams in the upper part of the watershed, so we don't even have the early amounts of sediment that the river once carried. So even though we have the levees down here, which are keeping from flooding, we probably wouldn't have enough sediments to offset the subsidence.
Well, Mark, how about Mississippi and other coastal states? Are they losing the same thing?
Well, in Mississippi, it's luckily we're very unique in that we don't have nearly the problem they do in Louisiana. But we do have an area in the eastern part of our state on the Alabama state line called Grand Bay. The part in Mississippi is a National Estuarine Research Reserve, and there was a stream that flowed into there thousands of years ago called the Escatawpa River. It was stream captured. It was sucked into, if you will, the Pascagoula River. So sediment, just like in Louisiana, is no longer flowing out to accrete the wetlands. And we also have a very strong southeastern wind pattern that's eroding some of the small barrier islands there and some of the salt marshes there. But pretty much in the rest of the state, it's not bad at all.
So it's more coastal barrier islands than it is coastal wetlands along that part of the coast?
Yeah, and we have some small barrier islands, but you can clearly see some erosion on the salt marsh from that southeastern wind, but it's not being replenished, as Kerry talked about. But it's a much smaller scale problem than we have in Louisiana.
Well, Kerry, you know, we know that this is an enormous problem. Why is it important to the citizens of Mississippi and Louisiana that these coastal wetlands are disappearing the way they are?
We have an enormous wetland loss issue, and the wetlands are a part of our culture. Aside from that, the wetlands produce an enormous amount of fisheries for the nation, and they house all the oil pipelines which are protected with the marshes and the oil infrastructure. Everything is protected with the marsh and ridge infrastructure. Our communities are very vulnerable now with storm surges. They could cause an increase in insurance rates. We no longer have the ridges and marshes to offset, to buffer that storm surge. So at the very least, they should be concerned for what the estuary produces, both renewable natural resources and non-renewable natural resources, as well as insurance rates that affect the whole country.
Mm-hmm. And not to mention the cultural impacts that we have along our coast. We're so tightly tied to these wetlands. Louisiana has done a number of things to try to mitigate the possible disaster of the oil coming in, including opening the river diversions to their full extent and building berms off of our coast. And it's been somewhat controversial. Tell us briefly about the building of the berms, and what do they look like and what are they supposed to do?
Well, the idea was that we'd build sand berms, on top of our barrier islands or in front of the barrier islands to reduce the amount of oil coming inshore. The problem with that is that this was a very hastily dreamed up, procedure, and it didn't have the scientific, background in building it. These were sand berms about 6 feet high, essentially sand levees that would be built, and they were subject to the wave actions from hurricanes and tropical storms, and the fear was that they would just be eroded away. But the biggest problem with building the sand berms is that it was using a sand resource that could have been used for legitimate barrier island restoration. We do need to restore our barrier islands, and everybody in Louisiana, all the scientific community supports barrier island restoration. But to build sand levees in the front of our barrier islands, you would have storm surges coming in, and to build sand berms takes a resource. They would harvest sand from where it is in the Gulf and deposit it on the barrier islands in the form of sand berms. And the wave actions from the hurricanes, storm surges, and whatever would disperse the sand all over the internal estuary, and it would no longer be available for legitimate Barrier Island restoration. That was the biggest fear. They were very costly. We built 5 miles of berm at a cost of $180 million. We restored Timberlayer Island, for example, pre-Hurricane Katrina for $12 million at about 5 miles of that Barrier Island. So they were very expensive, and we don't know how much good they did.
Yeah. Well, they've been very controversial, and the governor, it's been widely reported that the governor and other community leaders have called for building the berms and continuing the construction. At the same time that it's been widely reported that the scientific community is not supporting it, as you have just suggested. Why do those community leaders want to build these berms?
Well, there was a feeling that they had to do something. Everybody was concerned about the oil coming in Louisiana, and they had to do something. And the perception was that they would stop the oil from coming in, when the reality was that they didn't at all. You build a sand berm on the front of the Barrier Island, or you don't have that sand berm, and the oil hits the Barrier Island. So what's the deal? You cleaning up oil off sand either way. Right. The usefulness of the sand berms was questionable.
Right. And the scientific community is opposed because?
Because it was an enormous waste of resource.
Yeah. And also there's science. There's concerns about the science of the construction as well.
Well, the whole shape. The shape of the berms was in the form of a levee. The shape of the Barrier Island is not in the form of a levee. It gradually slopes. And, the shape was all wrong.
Mm-hmm. Yeah, and that has caused quite a controversy in our state and beyond, because it pits community leaders who are there to help the public against the scientific community that's been out there for decades working on these issues. So it's unfortunate. Regarding the diversions on the river, tell us what the Davis Pond Diversion Project is, and give the audience a feel for what river diversions are about.
Well, the Davis Pond diversion was actually thought of as a way to help oyster production. It has a maximum of 10,000 cubic feet per second of flow. It flows river water from the river, Mississippi River, into Lake Catawatchee. And the operation of Davis Pond is governed by a 5 parts per thousand line, which is down near Little Lake, down into the system. It's about where the 5 part per thousand line was in 1956. When the saltwater line at Little Lake becomes greater than 5 parts per thousand, they would release more water. So it was meant to introduce sediments and nutrients into the marshes to restore some of that hydrology that we lost over the years. And it was meant to do so in a way that we could still maintain oyster production. Oysters do need salt water to survive, and several estuarine species need salt water to survive and grow. But Davis Pond, there's a perception that you would fill the system with fresh water and create a positive flow and keep the oil out. Mm-hmm. But in Louisiana, we have a very weak tidal system. It's dominated by winds. Wind direction has everything to do with stacking up water in our internal system. So the release of maximum flow 10,000 CFS water from the river ended up killing oysters at a critical time of year, the time they were spawning. The success at keeping oil out was very questionable. In my opinion, it did nothing to keep the oil out of the internal estuary.
Yeah, well, that was my follow-up question, was is it being affected with the oil, and you say no.
No, there's no question. There's a perception that the positive flow would keep the oil out, but it's too far up in the system to impact the passes.
Yeah. Have there been any unintended consequences that you haven't mentioned yet from opening, at maximum capacity?
Well, it's killed a lot of oysters. We did oyster surveys, about 3 weeks ago, and all the oysters are dead in the upper half of Barataria Bay all the way up. And the concern there is that there won't be any spawning success to generate new oysters for the following years, next year and the years after that.
Yeah. What's your opinion on Dr. Marty McConnell at the University of New Orleans' assertion that had we had these restoration programs in place for decades, that we would have a healthy barrier island system?
I agree totally with that. We need land. The land loss area in Louisiana is critical. We've lost so much land that our communities are at risk. Salt water is encroaching into fresh water. We need to rebuild land masses.
Well, thank you very much. We appreciate you being with us today. Thank you for inviting us.
Thank you.
Well, we recently traveled to Louisiana to visit several state and private universities where scientists are studying the impacts of oil on the different habitats in the Gulf of Mexico and on the interconnectivity of the food web. Let's see what those scientists have to say.
The optimists say that, well, the oil is gone and we don't see it in the water column anymore. And then it turns up in a bottom layer. And some of the folks before this bottom layer was discovered say, well, the bacteria have worked exceptionally fast. It's just gone. We still don't really know. We don't know what the condition of that settled layer is. Is it largely degraded? Is it toxic? Are all the lightweight components out of it, the things that could likely be toxic? We don't know.
So there was that immediate oil hitting the shore, but a lot of that oil that's on the surface is now gone. Gone where? It's a really good question. But part of the answer is that some of it is still out there in the environment. It's lying on the bottom. And it's lying on the bottom close to coastlines. And so even though this initial surface oil has disappeared, we might think that the initial exposure has disappeared. But what's really important to keep in mind is that future storm events are going to resuspend some of that oil back into the water column and re-expose some beaches and some marsh habitats. And any critters that are burrowing down into that sand or burrowing down into the sediment of marshes where some of this oil is stored are going to be continuously exposed over a long period of time.
Speaking and hearing about some of the scientists who worked with the Exxon Valdez in Alaska, especially with their herring problem, and what the situation there was, this species was a commercial species doing fairly well. Right after the oil spill, a cohort came back. The next 3 or 4 years, everything seemed fine. But then later on, they stopped showing up, and then the problem started 4 or 5 years after the situation. And that's what we might be looking at here. We're not going to see an extirpation like we saw in Alaska. It's a different system altogether. But we have commercial species that have probably been impacted at the larval stage. They are not going to be around here in 4 or 5 years. We need to realize that. We need to kind of point out ways to mitigate that and long-term effects. And again, people say oil out of sight, out of mind. This is something that's going to be long-term, unfortunately, here in Mississippi and in southeast Louisiana.
You know, when you look at the ocean and you look at the obvious products that come from it, you see great big fish, and you see great big lobsters and big crabs and big shrimps, and that's what you see in the market. But there's an awful lot of background to this that you must understand in terms of how that gets there. How does it grow up? Where does it reproduce? What does it feed upon? What kind of habitat does it live in? They have these life histories that utilize all these different levels, and so they exemplify that it's all interconnected. You can't talk about that fish unless you're talking about the algae on the bottom in terms of, is there a good environment in which that fish can grow up in?
Well, I'm studying the diversity of the marine algae or the seaweed. So what I'm interested in is looking at what's out there in the Gulf of Mexico. And also now with that oil spill is how the oil spill could have affected the number of species and the quality of the species that was there before. So what is so important about the organisms I'm studying is for the whole ecosystem of the Gulf, for the vitality of the Gulf, is that they are the primary producers, meaning they are the ones that produce the oxygen. And we all know if there is no oxygen, the whole rest of the ecosystem is going to go berserk, basically. So that's why it's so important to have the algae that are healthy and not being affected by negative effects of the oil, etc., to really make sure that they can produce the oxygen and that the rest of the Gulf stays healthy.
But a lot of our questions about whether or not this is going to create a hypoxic or an anoxic zone in the Gulf of Mexico and beyond hinges on how much oil originally came out, how fast is it moving and mixing with the water mass and with other sources of carbon, and how long is it taking for that oil to biodegrade. In terms of landed oil, again, one of the fascinating things that we've noticed through our sampling is that the sampling is, or where oil is washing up, is very spatially heterogeneous. That's a fancy way of saying it's splotchy. You can be in one marsh and you can find oil up to your ankles, literally, and you can go a few miles away and not find a trace of the oil. So it's interesting how it's been transported from fairly far offshore into these sensitive ecosystems, and how natural currents have and wind patterns have coordinated into certain areas and kept other areas relatively oil clean.
So it seems like the event is over, and it's over for a lot of people that make their living here. But they make their living on the organisms that live in a lot of these marshes, or at least the ecosystem health is what supports a lot of this economy. And the effects on ecosystem health, I don't think we've seen those yet. Those haven't emerged yet.
The fears that folks have about will I see those communities come back that I've grown to depend upon being there, whether I simply go to the restaurant to eat them or whether I'm out there as a scuba diver or a fisherman enjoying that community for a variety of other reasons, will those be there again? I think we're going to be able to shed some light on that very soon.
So we see that there are many issues on a variety of levels relating to the oil impacts on the Gulf of Mexico. Let's turn to the scientists here today to discuss these issues in more detail. Bob.
Well, thank you very much. Our guests in this segment are both from the Gulf Coast Research Lab in Ocean Springs, and Dr. Mark Peterson, who you've already met, is a professor of coastal sciences at the lab. And our new guest is Dr. Patrick Biber, who's an associate professor of coastal sciences also at the lab. Welcome. Good to have you all with us today.
Good to be here.
A common theme that we've heard a lot about after the oil spill has been this issue of interconnectivity in ecosystems. And it's sort of a recurring theme that people keep wanting to talk about because it's very important. Tell us a little bit, Mark, if you will, about that interconnectivity of species, especially in the realm of food webs.
Sure.
How they relate to us as citizens of the coast.
Okay. It tends to be a complex sort of process, and it's hard for non-scientists to understand, but an easy way to think about it is organisms that tend to spawn offshore, for example, like crabs or shrimp, a number of fishes, move inshore into the salt marsh nursery areas for protection from predators, for food and whatnot. So that interconnectivity there, within that argument, they also feed in different places in terms of the food web aspect, and they utilize different resources, whether inshore in estuaries or offshore in the Barrier Islands, or even up in rivers. A lot of these systems in our part of the world are very river dominated, and a classic example of this is the Gulf sturgeon. And one of the fishes that I work on is a threatened species. They spawn upriver as adults, and they spend about 6 months upriver. They do not feed. And then they move back down. The juveniles and smaller individuals stay in the estuary proper, but the adults move to the Barrier Islands, and they feed all winter long, and then they start that cycle over again. And so there's a huge connectivity. If you put up dams, you put up blockades, they can't complete that life cycle. And these animals don't understand state lines or county lines or any kind of barriers. They just simply have evolved to sort of do things they do. And so if you break that connectivity, you break down the food web in many ways.
Mm-hmm. Well, Dr. O'Connell mentioned in the video about after the Exxon Valdez spill in Prince William Sound that the first year the herring fishery was very strong, and it was strong the next couple of years, and in the fourth year it absolutely collapsed. Knowing that you're not necessarily a specialist in herring, what does that really mean in the Gulf of Mexico? Are we watching that, see if it happens there?
Well, I think some people are probably doing that. I know there's probably three ways that you can look at this sort of longer term decline, if you will. One is there's immediate impact, so you impact the adult stock or the juvenile offspring that would become adults the next season by direct impact of the oil, and certainly a lot of that did happen. The second, and a little bit less understandable, is the impact on reproduction of these fish. If you can have a small impact early, and it might build from one spawning cycle to the next spawning cycle in adults, and that's sort of a cumulative impact to where you can then see the population size going down as the population size reduces because of reduced reproduction. Then your spawning stock biomass, the number that's out there, can be impacted. And third, the sort of long-term impact in my mind, because I work on juvenile fishes, the inshore component, when those that do survive and that make it in maybe on a lesser spawn from adults that recruit into salt marsh areas like we have, not so much Prince William Sound, but they can be re-impacted by any oil that might be still left in the sediment, because a lot of them feed in the sediment when they're juveniles down in these areas, and can influence themselves and such that they won't make it back to the spawning grounds as they get older. So there's probably 3 or 4, maybe even more of those. Herring is sort of an intriguing thing. There's been a lot of money and a lot of study of those for decades, and they still really don't have the answer. So it's not as simple as the oil's gone, right, fish are back this year, everything's great. It's much more complex.
Are there any particular species in the Gulf of Mexico that we're particularly concerned about?
I think I know that far offshore, some of our colleagues at the lab are working on bluefin tuna, and they're working on things like red drum and other sport fish. Jim Frank spoke here last time and talked about that, and so there's people looking at those exact things, but they're concerned about blue crabs, very important economically. They have this sort of estuarine dependent spawning offshore, moving inshore sort of pattern, shrimp as well. And you saw certainly after Katrina that the shrimp and crabs were really abundant because they reduced harvest of those. But now that they're back harvesting, they've come back to a level, and it's about where it used to be. So clearly Katrina didn't impact them as much as we had originally thought. But this oil hanging on in the environment, this disappearing oil that people keep talking about, until we figure out that impact, it could be a much longer process like they saw in Alaska.
Okay, yeah, that's very important. Dr. Suzanne Friedrich talked about her work with algae in the Gulf of Mexico, especially, she looks at how its presence affects the amount of oxygen that's bioavailable in the water column, and she's very concerned about the impacts on oil. Patrick, why is that so important? Why are scientists concerned about that?
Well, the seaweeds, like many of the other organisms that are primary producers in the Gulf, those include phytoplankton. They also include submerged aquatic vegetation, and people might also consider salt marsh plants being important primary producers. So all of those plants do produce oxygen as a byproduct. And they are important habitat as well for many of the organisms, including some of the juveniles of species that Mark talked about earlier.
Yeah. Well, Dr. Brad Rosenheim mentioned the problem with hypoxia and anoxia, the low oxygen, no oxygen. What is that? What does that really mean?
So generally, when you have these kinds of conditions, they tend to set up in the summer during warmer water conditions. Warmer water contains less oxygen. Usually hypoxia and anoxia set up when there's a lot of phytoplankton blooming. Those phytoplankton don't all get consumed by organisms. Some of them die and sink to the bottom and are then broken down by bacteria. As those bacteria break down the dead organic matter from the phytoplankton, they're using up oxygen and will quickly use up all the available oxygen in the bottom waters. The problem of that is that animals require oxygen to survive, so if there's insufficient oxygen to support animal life like fish or crabs, then you get a die-off. A big example of that in the northern Gulf is the dead zone just to the west of the Mississippi River mouth, which fuels large phytoplankton blooms in the spring with all the nutrients that come down from the river.
Well, Dr. Friedrich also discussed the algal communities that she studies mostly in deep water systems, but she's very concerned about shifting, that there might always be algae there, but it might go from large algae to a smaller form of algae. Does that have any impact on the fisheries that you study?
It certainly can. I mean, there's been enough work on that, looking at sort of shifting from one sort of community structure, if you will. Usually fish guys look at as vegetation as habitat for organisms. And if you shift that to a different kind, either a more structurally complex or a less structurally complex, you get different prey availability on those things, because, in part because of that complexity. And though fishes might shift to different places because of in many ways, food availability, protection from predators, the things that make juvenile habitat really important to these young, or habitat for these young juveniles. The other thing is that the normal prey that these things might feed on may not colonize a different structure. And so it's, again, a complex sort of thing, but the animals seem to know that. You know, and some new structural components may not make much difference, but some might make a big difference.
Mm-hmm. How about the shallow bed, grass beds that you work on, Patrick?
We haven't seen much effect of the oil on those plants at this time. It's a little uncertain as to whether there might be longer-term effects. I think we saw in one of the earlier segments, Alex mentioned that oil in the sediments of the marshes was a concern. Similarly, for seagrasses, they would have the same kinds of problems as the marsh plants, with oil in the sediment affecting the roots and potentially causing mortality. So yes, that is a long-term concern of mine.
Okay, good. Well, one of the things that Dr. Andrew Whitehead in the video was talking about the impact of future storms, where they might mobilize some of the oil that's offshore and bring it inshore where it comes in contact. What are your concerns about that? Do you really think that that's going to happen? Does the scientific community really have a handle on that yet?
I don't think we have a good handle on it, at least on the biology side of things. Certainly if there's significant oil in deep waters that's easily mobilized, that could come on shore, I could see that as a potential, problem for the next year or so, that we may see some oil coming up into the nearshore environment because of this deep pool. But it depends a lot on how quickly that oil might degrade and how quickly it might also settle out into the sediments, where it would be a little less available to be moved.
Right. So even though we don't know about it today, we think that it'll lessen as time goes on.
I believe so, yes.
Yeah. Well, thank you very.
One little interjection.
Yes.
One thing about marsh sediments is that it can get buried very quickly, and a lot of times when it's re-exposed, it sometimes in the literature would suggest that it still can be somewhat toxic. So it may not always go away, or might not always be broken down, because if it's separated from the oxygen, it's more problematic breaking it down.
Well, that's an excellent point.
Marshes.
Excellent point. Thank you very much for being with us today.
Thank you.
Thank you.
The BP oil disaster has created an unprecedented opportunity and need for scientists to create new ways of working together and to share data. Scientists from several Louisiana universities gave us their thoughts on these opportunities and avenues of scientific collaboration.
I think with the oil spill, and I'm being hopeful here, it has made researchers realize they have to work together. It made researchers realize the value of their work. It goes beyond just having a publication. This is a way of recognizing the value not only of us in academia, but also the value of the people in the federal and state agencies who have these data, who are now actually newly, this is something new, federal agencies releasing the data from certain aspects in the Gulf. So it is something. I think it's a new opening, and the idea that this is an excuse we need to start sharing data just for the benefit of the public.
It actually shows how different fields and different sciences can come together and provide a better assessment for the impact of disasters. For example, in our project, it shows how physics, ecology, mathematics, statistics can all be combined to provide an assessment of the BP disaster on the marine mammals. Furthermore, recently we've been contacted by NOAA. NOAA is actually performing similar acoustic experiments. So we started now discussion, and we hope that whatever data and analysis we conduct and whatever data and analysis they conduct can be shared, and hence instead of one data set, we will have several data sets providing corroborating evidence whether there has been an effect to this species or not.
This spill, scientifically, and I'm probably speaking for a lot of scientists, not just myself, but it's opened up a lot of new collaborations. As I said, I'm a paleoclimatologist, a paleoceanographer, and I use geochemistry as my tool. different aspects of geochemistry. That also turns out to be a very good tool for tracking oil, especially as it gets incorporated into our environment. So this has opened up collaborative doors for me to work with other scientists, some who've had a lot more experience working with oil, which is necessary because I need to learn a lot from them, and hopefully they'll learn a lot from me. So there have been opportunities that come out of this in terms of being able to ask new scientific questions.
So what scientists have to get a handle on is some integrated measure of exposure of sensitive habitats across the Gulf. And there are lots of sources of information there. Many of them are dispersed between different agencies and different groups and in different areas. So what is really important is for us to figure out a way of integrating all those sources of information from people on the ground saying, I have a georeference site of oil here, versus people that have a chemistry sample from that site, where they've done the analytical chemistry, people that have a sediment sample from that site, and also integrating all the remote sensing data from the satellites into some integrated measure of exposure across time and across this geographical region. We need to figure out a way of having a central, searchable database to access those data from.
The work that Chris Jenkins does at the University of Colorado with his program DCBED, it's very cutting edge, the fact that they can actually bring these data together and make them work together.
If you want to see the interconnectivity of disciplines, this is the time that it really is exemplified. Everything from a good writer, a good reporter, to someone who understands microbes is important in a situation like this. I am not a microbiologist, but I live and die right now by what the microbiologists are telling me about the decomposition rate of oil, and I've read up on it and I've had to learn about it. That's a totally different discipline from my own. By the same token, I'm not a geographic information system person that's doing a lot of the mapping, but it's mighty important to me right now how you map out this oil spill. And so we're the biologists in the middle, and there's many kinds of us. There's thousands of different kinds of experts that are needed right now. So it may sound like, oh gosh, here goes another expert shooting off his mouth. We need many different kinds of experts right now. They do need to talk to each other. They need to use each other's information.
So we see from some of the scientists we visited that they are working in ways as never before across disciplines with others throughout the country and with the government to conduct research and share data. Dr. Bob Thomas has more on how scientists are coming together. Bob.
Good, thank you. Our guests in this segment are Dr. George Crozier, the director of the Dauphin Island Sea Lab in Alabama. Welcome. Thanks, Bob. And Dr. Jeff Lotz, the Department Chair of Coastal Studies and Professor at the Gulf Coast Research Lab in Mississippi.
Glad to be here.
Good to have you with us. Well, this excitement is really fun for scientists, where all of a sudden people are collaborating that maybe used to be even in different buildings. And now we sit and talk about issues, and we bring into the conversation some of the things that our specialty into your specialty, and all of a sudden we come up with new ideas. One of the celebrated ones that I like to use with my students is dinosaurs. You know, when we were young, you knew about 5 or 6 dinosaurs, and everybody knew what they looked like and had this image of what they looked like. And then all of a sudden in the 80s, you know, a functional anatomist walked into a paleontologist's lab and went, you know, you really think that dinosaur stands like that, but it doesn't, because that bone would have to have a muscle mass that looks like this, which would make it stand a certain way. And another one walked in and said, you know, I've looked at cross-sections of these bones, and I'm starting to think these things are warm-blooded, not cold-blooded, which means they move fast. And all of a sudden, the gaits, the way they walk, the way they feed, the way they interact, changed markedly. And the rest is history, what we see on Discovery Channel today about dinosaurs. Is this happening in your institutions, especially in relation to the oil spill?
Well, I think the reaction is curiosity, and it's certainly beyond buildings. I think one of the more interesting ones, we had researchers come to the laboratory, which of course is essentially out in the middle of the Gulf of Mexico, and clean the south-facing windows scrupulously so that they could come back after a storm and look at what might have been blown in or aerosoled onto the landmass that the island represents. We've also been engaged in trying to get the scientists from around the state involved, which was an interesting exercise for us. We had workshops where 115 scientists from 13 different institutions came together to work out a plan to try to do immediate research at the Gulf, and this was different for us.
Jeff?
Well, yeah, we have a number of collaborations going on. You know, science generally is a deliberative and a collaborative endeavor, and it provides not only expertise of different expertises coming together to look at the similar problems related to the oil spill or anything else. It also provides checks and balances. For example, if a scientist has some data and wants to publish a paper, it's sent out to other scientists for review to make sure that you haven't made a big error and your assumptions and your methods are correct. And so that collaborations are very important at that level. There are also the collaborations that were mentioned earlier in the introductory piece that it's important to bring expertises together that are different, and that creates several problems, the most important of which in this day and age with large amounts of data and large amounts of the ability to transfer data is where are you going to put that data and where is it going to be and how are you going to vet it? Nobody wants to put just raw data out to be looked at. You certainly are. But we have collaborations all the way from the University of Southern Maine to the Hopkins Marine Laboratory in California. But most of our collaborations are in the Gulf of Mexico where the primary expertise, I believe, is in the Gulf of Mexico.
And you're crossing disciplines when you do that as well, not only spreading it around the country and the world, but also crossing disciplines and bringing to bear their information and their perspectives.
Yeah, we have microbiologists, and certainly my area is really in the biological sciences. I'm actually an aquaculturist and look at infectious diseases in marine organisms, but in this day and age there's a lot of interest in gene expression. You mentioned the switch over in the dinosaurs from the old lethargic organisms to pretty fast sort of bird-like organisms. Well, the genomics or the gene expression is something that's coming into play, and you can recognize some stresses through that activity that wasn't available as short a time ago as Exxon Valdez.
Well, I think one of the intriguing things is that the chairman at the lab had come up with an early cliche, and relative to this oil spill, his attitude was, we don't even know what we don't know, which is a very cute cliche. It doesn't get you very far down the road and where you need to be. And I think that this part of the problem that we're dealing with is the urgency of these issues. People wanted to know what was happening, and of course they wanted to know what's going to happen, and that was a terrible mystery for all of us. We'd never experienced anything like this in our environment, and it wasn't particularly useful to transfer Exxon Valdez to the Gulf of Mexico. The circumstances were so very different. And this is, I think, was what was frustrating to me. Everybody within 300 miles of my voice knew what the hurricane would do if it came. And they want to know what's going to happen when this comes. And that was hopeless. We had no clue. And it's made it very difficult to anticipate what we needed to do in terms of research also.
George, the most commonly asked questions these days, and I'm talking about in conversation over coffee, in front of somebody interviewing you in the media, is where has the oil gone? What's your comment?
Well, I think what bothers me is that it's actually fairly honest to say that it's not oil anymore. And I think there's a misunderstanding or a perception of what crude oil was. And that oil started weathering the moment it hit the water 5,000 feet down in the Gulf of Mexico. And so the issue has become now is where is the carbon that was injected into the north central Gulf of Mexico that way, and in what form is it? Is it toxic? Has the microbial community really degraded this substance to the point where it's all carbon dioxide, or is it turning into bacteria that are going to be eaten by copepods to be eaten by fish that go all the way up the food chain? And are there going to be toxics? What components are toxic and remaining in this system? And those are the long-term questions we're going to be stuck with for a long time. So the oil may be gone, but the product of the oil and being exposed in the Gulf of Mexico remains there, and that's going to be the challenge, I think, to the scientific community, is to answer that big question.
Right. Yeah, for the lay public, you know, we heard back on August 4th when NOAA made their pronouncement, they used the phraseology, only 26% of the oil is unaccounted for. Public took that to mean that it's all gone except for 26%, but in fact it was accounted for. the rest of it. So that's, Jeff, do you have anything
well,
to add to that?
it certainly is. I mean, you say, well, the oil is gone because it doesn't float. We don't see anything on the surface and oil floats, but as George said, it's not oil anymore. It's weathered oil, partially degraded oil, and it's going to be around for a long time and has been around for a long time. And the issue of how toxic it is certainly one that needs to be addressed, and we in the Gulf of Mexico are well able to do that. We raise a number of species that are native to the Gulf of Mexico in the laboratory that can be used for studies on the oil that is in this condition, not the oil that is crude as it comes out of the ground, but the way it is now, and try to determine what might be the short-term as well as the long-term effects on that.
Well, those are excellent points, because we're still thinking of this as crude oil, and it certainly isn't any longer. And so what the scientific community is dealing with is figuring out not only what's happening out there ecologically, but how is the product that we're monitoring changing, and I think that's very important. You know, another thing that is on everybody's mind and has been repeatedly reported is a comparison of what happened in Prince William Sound to what happened with the Deepwater Horizon oil spill. What are your comments on that?
Well, the comparisons are very poor. A known volume of oil on the surface, close to the shore, delivered rather rapidly to the shoreline. We're dealing with oil that was released 5,000 feet down in a relatively warm environment compared to Alaska. Now it's cold down at 5,000 feet. And I think the question has become, ultimately what we're going to have to decide is whether the use of the dispersants that kept some significant portion of the oil in submicroscopic droplets, which is fine. That's a bacteria-sized, bite-sized particle. That was the whole point of using the dispersants. And I think that has left us with a lot of uncertainty, because it's at 3,000 feet or deeper. It's not even on the shelf, and how long it's going to be there and in what form. And we're going to have to balance that against the question, how bad might it have been on the shoreline if we had not used dispersants? And I don't think anybody really has the answer. The people that are confident about the dispersant being effective are saying, oh, it's going to be fine. There are those of us that are saying, well, we don't know much about deep water in the Gulf of Mexico, and there's a lot of carbon out there. We don't know what form it's in. We don't know what percentage is toxic, and we don't know the impacts on the microscopic community.
Right. And I think the average person is thinking of that they're thinking deep water, but they're thinking the surface world that we all live on. They're not realizing you're talking about 150 atmospheres of pressure down there. Just above freezing. It's a totally different environment as well.
And so comparisons to Exxon Valdez are hopeless.
I think that's exactly right. The Exxon Valdez was quite a different animal. However, there are a few things that could be learned from it, and some of them is that there are long-term effects for these oil spills. We saw that in Prince William Sound. So at least we should be prepared to look at this over the long term. Certainly, it was in one of the intros earlier on where they talked about the herring, which is at the base of the food chain, being depleted and not coming back, and after 4 or 5 years. And so these long-term effects from oil spills, whether they're acute, and they're not just acute events, and that's what needs to be kept in mind.
I think one of the things that's going to emerge from this, to get back to your collaboration question, Bob, is that one of the things that we're very excited about is that we're providing a new laboratory space to the Food and Drug Administration laboratory. They have analytical capacity that my little laboratory would never have, but we have the capacity to bring them samples from the environment, which they can then analyze. So we're looking at a long-term relationship with a federal agency that I think is going to bring a lot of power to bear on this long-term question. And that's really what it's going to take. I mean, we're faced with, as from Exxon Valdez, 20 years of looking at very subtle effects in the ecosystem, effects that probably only people like us will actually appreciate in every sense of the word. Hopefully that it's just that subtle.
Right. But we don't ever know what the application of those subtle differences are.
No, exactly right. And we have collaborations like that George is mentioning at our laboratory. We have a Gulf of Mexico marine hatchery program, which is an aquaculture program, which aquaculture, because we do raising of animals for food in closed systems, weren't affected by the oil, but in fact there's an opportunity to do land-based marine aquaculture to provide animals for studies, as well as to provide, we do know that seafood production out of the Gulf of Mexico during that period was well reduced, and here's an opportunity to look at a way to maybe fill in some of those gaps. And if anybody were in fact lost their business because of the complications of Hurricane Katrina, as well as perhaps not being able to fish during this, that aquaculture is an opportunity, and that's a collaborative program that we have in our laboratory.
Excellent. Well, look, we have just a minute left in closing. Do y'all think that one of the positive outcomes here may be that the nation refocuses some of its interest in studies of the Gulf of Mexico?
Well, I think that the fragility of the system has been more than documented. Right. I think there is going to have to be that concern. And in the wake of Katrina, I hope people will put the two together.
Certainly there's been a bit of a shift in recognizing across the nation how important the Gulf of Mexico is, and I think it's been very much understudied and probably undervalued, and when we hope that we can maintain the interest of the country and the scientific community in the Gulf of Mexico for a long time.
Well, thank you very much. We appreciate you being with us today.
Thank you.
Thank you, Dr. Thomas. Now, we also want to let you know you can find more on our companion website at SpillScience.com. There you can find in-depth information about topics related to the spill, as well as video discussions from scientists studying the effects of the spill on the Gulf of Mexico. You may also want to join the discussion on our blog section of the site, where you can engage in discussions with scientists studying the impacts from the Deepwater Horizon oil spill. Again, that's SpillScience.com. And that's all for this edition of The Science of the Spill. Until next time, I'm Erin Pickens.
And I'm Dr. Bob Thomas.
This program was made possible by a grant from the National Science Foundation, a co-production by Mississippi Public Broadcasting and the University of Southern Mississippi Gulf Coast Research Laboratory.